Yeah, we can do that. All right, so we are switching gears back to the arithmetic. All right, we're going to go back to the 4 arithmetic operations. But now we're going to pay attention to domains. Because in the instructions here, look at the instructions for this section. It says here, okay, you're given the functions f and g, right? You're given the functions f and g. Find the following, right? So you have to find the sum, the difference, the product, the quotient, and then also, what? Find the domain for each part. So each part you do, you have to find the domain of. So we're going to do 78. So our 2 functions that we're given, let's see here. F of x is the square root of x minus 1. And then g is square root of 4 minus x. I'm sorry that there's not more time for us to sit here and be like, hey, now let's let you do an example and we sit here and have fun and, you know, bring in popcorn and pizza. We don't have time. I got to get through this material, right? So I'm trying to show you as much as I possibly can. I know that sucks on your end to sit there, but yeah, it is what it is. All right, let's add these together first. If we add, oh gosh, if we add, that just means add them, right? Just add them up. So I take my square root of x minus 1, I add to it the square root of 4 minus x. Can you add those together? Is there any operation you can do to put those together? They're not like radicals. You have to have the exact same thing underneath the roots for us to put those together. So there's absolutely nothing you can do to that. That's it. That's the sum. Okay? Why are y'all looking at me like that? What's wrong? You all right? What's going on?
Could you explain it like a little more in depth? Why that's the case?
Okay, so if I say, thank you. If I say square root of 5 plus square root of 3, can you combine those? These would be considered to be not like radicals because they don't have the same thing underneath them. Now, if you had square root of 5 plus, let's say, square root of 5, then you could say, yes, that's 2 square roots of 5. Why? Because this is like an apple plus an apple is 2 apples. But see, this is an apple plus an orange, and you can't do that, right? Same idea here. This and this can't come together because what's underneath them is not identical. That help? Everybody okay now? Okay. So we're done. Same thing with subtraction. Oh, domain. Sorry, we didn't talk about domain. What's the domain of this? So do you see any division by 0? See any division by 0? No. Okay, see any roots? 2 of them, right? You have to address both of them. So looking at this first root right here, we got to make sure that that is what? Greater than or equal to 0. Is it okay if we put 0 there? Yes, because you won't have division by 0, right? And then, so we're gonna look at that, and then we're also gonna look at this one. What do we need for that one? We need that to also be greater than or equal to 0, don't we? Solve the first one. How do you solve this linear inequality? Add 1 to both sides. Do you know what that looks like on a number line? X bigger than or equal to 1? 1, closed, included, and then to the right forever. So to satisfy this radical, we need to make sure that our x values are from 1, including 1, to the right forever. Anything there would work and make that one okay. But we have to do that one as well. How would you like me to solve this? There's 2 ways to do it. I can either add x to both sides, or I can move the 4 over and then get rid of the negative x. Add x. If you add x, you do not have to worry about flipping anything. You get 4 bigger than or equal to x.
Split it into 2 equations?
You're going to have 2 different intervals, and what we need to see is where they overlap. What do they have in common? Okay, so for this one, we're at 4. And can I include 4 or not? Yes, because it has this, so 4. And does this mean the stuff bigger than or smaller than 4? Smaller. X must be smaller than 4. So to the left, right, we can have anything over here, right? So the only thing that'll make this addition of these two functions work is if we pick x's that are bigger than or equal to 1, but at the same time less than or equal to 4, which means everything between 1 and 4. So my final answer for this one, for the domain of f plus g, right, is bracket 1 comma 4 bracket. Any questions? All right, I'm going to cheat a little bit. I'm going to do the subtraction one now. If we change this to minus, what happens here? That becomes a minus. Can we put them together? No, for the same reason, the apples and oranges. You can't subtract these, okay? Yes?
Wouldn't the second one become a negative one? You have to distribute one.
Well, you can't distribute a negative into
No, like to the whole thing.
to the whole thing.
Yeah.
You can't put, yes, it would be a negative root, but you can't put that negative in.
No, I'm not like not putting it in, but like wouldn't the whole thing become a negative root?
Yes, but it's the same thing. If I put negative root 5, that's the same as putting negative and then like root 5. Because the negative can't go anywhere, all you can do with it is put it in front, right? So if I change this to a minus, right? Change that to a minus, have subtraction, that's a minus. We can't put them together, right? There's nothing we can do algebraically, put them together. Do we still have to check the domain? Yes. Would it be any different? No, it'd be the exact same domain. So we get the same answer. Okay, so I'm not going to show that one. But if you do subtraction, you get the same domain. Now let's do multiplication. All right, for that one, I'm going to do it over here. So if we do fg, like that, of x. Now we're going to take the two functions and multiply them, right? And multiplication is different than addition and subtraction. There you don't have to have like radicals to put these together. And we have a property from back earlier in this class, that if you have the root of x times the root of y, you can do the root of xy. In other words, you can, if you have two roots being multiplied, you can just put them into one root and multiply what's underneath them. So I can make one root out of this, and I can take the x minus 1 and multiply the 4 minus x. That's this property right here being applied to that. And couldn't we multiply this out? We could, right? We can multiply this out. So if I multiply this out, let's see what we get. Square root. Less. Okay, that's enough. No more. Okay, 4x minus x squared minus 4 plus x. There we go. So I did the expansion, and I'm going to collect like terms. Negative x, I'll put it in descending order, negative x squared plus 5x minus 4. There we go. That is the product of those two. And now we have a freaking problem. All right? We have a problem. The problem is that I know already that the only way to define this, right? The only way to define this is to what? Make sure that x is bigger than 1. The only way to define this is to make sure that x is less than 4, right? But when I put them together, I get this, right? I get this when I multiply them together. I need to now look at this and ask myself, what would make this negative, right? Like, what's going to cause a problem with this? We haven't done that yet, have we? We haven't seen that. How am I doing on time here? Okay. What do y'all think? Do you think that the domain of that product, that this domain here, do you all think that this domain just inherits the domain of the two that we had individually? Like here, it's greater than 1, right? Here's less than 4, so it's got to be everything between 1 and 4. Do you think that this, if we multiply two functions together, that it just inherits the domain of each of them individually? You don't think so? Wouldn't it be nice if it did? It'd be nice, right? Does it, though? That's the question. Does it, right? You don't think so? You don't know, right? But do you understand that that's a question, right? We have to try and understand this. And this is somewhat of a complicated idea, but anytime you think about domains, when you put functions together, you always have to consider them individually first, okay? So individually, do we know the domain of this? Yes. Do we know the domain of this? Yes. That never changes, okay? That domain that we have right here is fixed, okay? Now we're going to multiply them. All we need to make sure is that when we multiply them, we don't add more restrictions to this. We might actually add more restrictions than just this. But this for sure is still going to stay the same, all right? So it's kind of good news and bad news. Good news is you kind of know part of the answer right now. You just need to make sure that we didn't have some new restriction get created over here. Now, the way that we can tell whether or not we did have a restriction or not is by, well, there's a couple of ways, but I'm going to try and see if we can think through it, okay? With this right here, let's go back before we multiplied it out, right here. When you look at this right here, when would we ever have a problem with this? Think about this, square root right here. This would be a problem if this was what? Negative and this was positive, right? Or the other way around. If this was negative and that was positive, wouldn't that cause an issue? Okay, but what is our domain so far? Our domain is this. I'm only plugging numbers in between what and what? 1 and 4. So think about it. If I plug a number between 1 and 4 here, is that ever going to be negative? What's it? If I plug numbers between 1 and 4 right here, what can you tell me this is always going to be? This will always be a positive, won't it? As long as I'm plugging numbers between here and here. Now, it could be 0, couldn't it?
Yeah.
But other than that, it would be positive, yes? And then what if I plug in numbers between 1 and 4 in here? The worst it could be is 0, right? But that's also going to be positive as well, isn't it? So I'm never going to get like negative and positive or negative and positive. It's always positive and positive, isn't it? So there's no additional restriction that I'm going to have to worry about with this. So my domain is what this was. Now let me do the quotient, and when I do the quotient, I think you'll see this you'll see we're going to have an additional restriction. So when you see that, I think it'll hopefully make a little more sense. All right, let's do the quotient. For quotient, so domain, the answer to that is that the domain is this as well. So for the quotient, if I do f over g of x, I'm taking the square root on top, right, this one, dividing it by the square root on the bottom, like this. And again, I already know that this domain is in effect, right? This domain right there is in effect. That doesn't change because I'm still working with the two functions to start. So that domain is absolutely has to be there. But do we have any additional restrictions? Who sees it? Raise your hand if you see it. Yeah, hold on. I want to give everyone an opportunity here. I don't want this class to turn into one of those classes where we get the same people over and over, but if people don't want to respond, I'm going to let people respond. So I want to give people a chance. I was talking to my daughter about this yesterday. She's taking geometry, and she was like, some of the students around me, they just, they take forever to figure it out. I'm like, okay, but that's okay. Like, you'll get to a point, I'm sure, where it's going to take you some time too. It's easy for her now, but I'm like, you've got to let people have to process information, right? So process, you got an answer? X can't be 4, right? X cannot be 4. Now here, in our domain, it could, right? Here it could, if we look at them individually. But because we create the quotient, we can't plug 4 in here or we'll get division by 0. So we have that additional restriction that we didn't have when they were separated. Understand? Yeah? Okay, so we will just say, okay, well, this, right, 4 minus x, we want to know when it's 0, right? Because that would be a problem. And that means x, that happens when x is 4. So we want to eliminate that. So what we'll do is we'll just change this bracket to a what? Parenthesis. That's it. And that will eliminate that 4.
So would that mean the domain is not true for all of them?
For, what do you mean?
All the different
All the things we've done?
operations?
No, each function operation has its own domain. So the sum has its domain. This difference has its domain. Yeah, each one is individual, or separate from one another. Okay. Let me see where we are here. I think I'm ready to cut you loose on the homework, yes? So now officially 3.1, all the homework that's listed on the calendar over there, you want to try and do everything there. And let's say we'll do a quiz. Yes. Right? You excited? We'll do a quiz on Tuesday. We're not leaving. Don't get too excited now. We're going to do a quiz on Tuesday, all right? And that quiz is going to be over 3.1 only, all right? Hold on. 3.1 only. And what I'm going to do is I'm going to give you 2 problems. I'm going to give you a difference quotient problem, and I'm going to give you one of these problems here with the arithmetic, right? And ask you for the domain. And you will choose which problem you want to do. You're only going to do one, all right? So if you feel better about difference quotient, it'll be difference quotient. You do. The other one will be the other one, right? So one problem, one of each. Now, because I've kind of gotten you into this habit of thinking your quiz is going to come straight from your homework, this quiz will not be straight from your homework. This quiz will be just problems I make up. You are allowed to use your notes in your homework on the quiz, but you must work alone. All right? So you can use your notes, you can use your homework, you know what's coming, but you don't know what problem's coming because it's not going to be a homework problem. Sound good? Okay. That's more like an exam where you don't know what problem, like you may have never seen it before, right? But at least you'll have your notes in your homework to work with. Yes?
For the first exam, can we have like a sheet with like equations?
We're going to talk about that. I will most likely allow you to have what I call a reference sheet, which is a sheet that you can write down like steps and procedures and formulas on, but you can't just work out problems. Like you can't just work out a bunch of problems and be like, that's my reference sheet. Yeah. And I don't like doing that in a class like this because when you get to like calculus and stuff, you don't get that stuff. You get a generic formula sheet from the back of the book if your professor allows you to. A lot of calculus professors don't. They make you memorize them. I don't do that for my students, but some do. So I don't want to like give you some false idea that the rest of the way through your college you're always going to have these reference sheets and all this other stuff. All right, we've got 15 minutes. Yeah? Yes. Oh, sorry. Yes. Uh-huh.
If I don't understand any of this, I can just go ahead and text you or email you, right?
Well, depends on what you text me and email me. If you text me, hey, I don't understand any of this, there's not a whole lot I'm going to be able to reply.
If I text you the problem and then what I've tried so far.
Yes. Oh, absolutely. Yes. If you're working through a problem and you're stuck, you're not understanding something, the best thing to do would be to text me a picture of the problem, picture of what you've done, and then ask me a question.
Okay.
Yes. That's the way I prefer to have it happen. All right, we're going to move into 3.2. I know you're exhausted. It's been a long week, right? Okay.
Yeah.
I think you're going to like 3.2 better than 3.1 because 3.2 is very visual. So we're going to be talking about functions. The title of this section is 3.2 is the graph of a function. The graph of a function. And so that's visual, right? Graphs are visual. Visual representations of something. So remember last class, recall from last class, this is 3.2, graphs of functions, just so we know we are switching into. All right. Okay, sorry, I went off on a completely different thought. So graphs of functions. Recall equations, right? Equations from last class in this idea of a relation. So if we had something like this, y squared equals x, we talked last class about how maybe you could look at that where you could say that y is a function of x or x is a function of y. We talked about the difference between those two statements. But what I really was trying to get you to kind of understand is that for it to be a function, right, it meant that for every input there's only one output, right? For every x you put in, there's only one that comes out. So is this a function of x? If I give you an x value, like let's say 4, is there only one y or are there more than one? So plug in 4 for x. Think about that equation. Is there more than one y or not? Replace x with 4. Replace x with 4. What number squared gives you 4? -2 and +2, which means there are two values, right? There are two values. So is this equation, this relation, can you say from that y is a function of x? No, right? It's not. You could say x is a function of y, but not the other way around. The reason, again, that this is not a function is because you have an input that goes to two outputs, right? What we do when we talk about graphs of functions is we're trying to get a visual idea of the relationship between the input and the output. So instead of drawing things like this, where 4 goes to 2 or something like that, what we do is we draw the x and y axis. I know a lot of you are familiar with this. We put x here, we put y here. This x-axis represents our input. The y-axis is our output. So look at this relationship right here. If x is 4, so if I go to 4 on the x-axis, what are the two y values I get out? 2 and -2, right? So if I go up 2, I put a dot. I go down 2, I put a dot. That is a visual representation of what just happened with this number, right? But we know that that's not a function. Let me try 0. What happens if I plug 0 in? What do you get? So you get y squared is 0, and the only number you can square and get 0 is 0. So that actually is okay because it doesn't go to two places. But it's already not a function of x because of this. If I were to plot that relationship, 0 goes in, 0 comes out, I plot that as this point, right? 0 is the x, 0 is the y. So these are like ordered pairs. This first one here is like the point 4, 2. This one is like the point 4, -2. And then this one is the point 0, 0, right? So the graph of a function is a visual representation of the relationship between the x and the y's. This is not a graph of a function, though, right? This is a graph of a relation, but not a function. And the key idea here that kind of like, if you just look at this, the thing that tells you right away that this is not a function is that if you draw a vertical line right here, you hit in two places. And that tells you that for one input, you had two outputs, right? One input gave you two outputs. So that vertical line that I drew automatically tells me this is not a function. And we have a test for this. If somebody graphs a function for you, or graphs something for you, if you want to check to see if it's a function, hold on, let me see, where is it? I thought I put it on here. All right, it's over there. Sorry, it's over there, but you have this thing which a lot of you have probably seen, and you know how to do the test. It's this thing called the vertical line test. If somebody draws a relation for you on the board, which is basically some sort of relationship, you can quickly tell whether or not it's a function by using this test. So I want to give you another example, or like a first example. I'm going to graph something for you. So look at this relation here. Here's the graph. Goes up, zigzags back, and goes like that. Now, what you see here on the board is basically a bunch of points. These are all points. Each one of these points, x and y, satisfies some relationship that I haven't even given you, all right? But here's, if you put all those points together, here's what the graph of that looks like. My question is this a function or not? No. Why? Because if I draw a vertical line, I hit it more than once, right? Everywhere? How about that vertical line? Do I hit it more than once? No. Here? No, not until I get to about here, right? Then I hit it, what, here 3 times, right? The vertical line test says if you're looking at the graph of a relationship and you want to know whether or not that graph is a function, then every vertical line you draw can only hit the graph at most in one point. If it ever hits more than once, it's not a function. So students like this because it's kind of easy, right? It's an easy test. Is this a function? Is a circle a function of x? No. Okay, if I draw this vertical line, do I hit more than once? No, okay. How about if I draw this line, do I hit more than once? That one right there that just hits there. I didn't hit more than once, right? So far, so good. Not until I get in here, right? Then I'm hitting what? More than once? There I'm hitting more than once. This is not a function. So not a function, I'm just gonna put F. This is not a function, right? To pass the vertical line test means it would have to look something like, how about this? Does that pass? That passes, right? That is a function. No matter what vertical line I ever draw, I'm only going to hit the graph one time. All right. Now let's talk about domain and range. Let's say you're given a function. I'm gonna go with how am I doing on time? 5 minutes? Okay, we'll just do one of these. Domain and range. Okay, I'm going to draw a picture for you. 1, 2, 3. 1, 2, 3. Okay, I'm going to draw something for you, and do your best to copy. It doesn't have to be perfect. That red graph you see, it represents all the points for some relation between x and y that I haven't given you algebraically. I'm just giving you the picture of it. My first question to you, is this a function? Yes, it's a function because any vertical line I draw hits it no more than once. So it is a function, right? Yes? Okay, now I'm going to ask you, what's the domain? The domain is, again, like we started class with, the domain is what are the values of x that you are allowed to plug into this function? So by looking at this, can you plug in -1 to this? -1. Okay, so negative 1's over here, right? That x value is negative 1. If I plug in negative 1, do you see any picture over here? No. How about negative 2? No picture over here, right? So in terms of domain, we're looking along the x-axis and we're trying to say, when do we start seeing picture? So where does it start for us?
0.
At 0. At 0, I get a point up here, right? So my domain, right? My domain is starting here at 0. And then as I move to the right, do I have picture up there? I do, right? I have picture until I get to where? 3, right? I have picture all the way, graph all the way until I get to 3. Now at 3, can I plug 3 in? Why not? There's a hole, right? There's a hole. So this function is not defined at 3. There's a hole there. So my domain would be, of this function f, would be bracket 0, right? 0 to 3. And I will stress to you that these are x values, right? These are the x values that we're looking at. This graph exists between x is 0 to 3. Now, anyone have a question on that? We're almost done. Let's talk about range. Range are the things that come out of the function, which is the y values. So let me ask you, down here, negative 2, does this function ever spit out a point down here at negative 2? No? How about negative 1? See, I'm looking at the y-axis instead. How about 0? Does that graph ever give a y value of 0? Almost, right? Almost? But there's a hole there. So from 0, not including 0, how about right above that? Yes, there's a y value here. There's y values this whole time, right? Until I get to where? To 3. Now, does the function ever achieve the value of 3? Yes, so it's a solid dot. So my range, which we put RAN of f, where did it start at? 0 to 3. Do I include 0? Do I include 3? Yes. Remember, these are your y values that come out. So I know we went through that quick, but the idea is that if somebody gives you a graph of something, you should be able to tell whether or not it's a function by doing the vertical line test. And then by analyzing left and right, you can find the domain. And up and down, you can find the range. We'll do more of that next class. Don't worry about any homework from 3.2. We will go through 3.2 fast, though, because it's going to be quick, probably 20 minutes next class, and then we get into the next section. All right, do your homework. Remember, quiz, right? Okay, y'all have a great weekend.
I'm really worried about my grades, so.
Okay, hold on. I'm still on camera. Let me.
Oh, my bad.
No, it's okay. I just want to mute myself.